Replace your corporate VPN with sponsored TrustGrid and connect your cloud resources to on-premises data. TrustGrid is automated, software-defined, self-patching, supports modern standards like OpenTelemetry, and was built by networking nerds.
Learn more about TrustGrid at trustgrid.io/packetpushes. That's trustgrid.io/packetpushes.
On today's N is for Networking, we are going to continue our discussion of spanning tree. This thing turned into a monster, guys. And so we took last week's huge recording and split it into two chunks. And this is the second part of that. Episode 15 is a continuation right where we left off at the end of episode 14. I'm Ethan Banks. I've been doing networking since the 90s, and with me is Holly Metlitsky. She's newer to networking. She collects certifications, and she helps her customers each and every week to buy the right things. And together, we navigate the modern networking landscape, helping you understand the technical fundamentals of moving packets around. You can find us on LinkedIn and the Packet Pushers community Slack group, which you can join free forever at packetpushers.net/community. Today's part 3 is the final episode from this listener question, and that question was, it would be great to go over spanning tree. It is a mysterious thing that I don't fully grasp. BPDUs, root bridge, edge port, forwarding, blocking. When I've asked others to walk me through all this, the usual response is just to disable it. Ooh, so is that what we want to be doing? And that is what we're going to continue our discussion about today. In today's episode, we are going to dig into spanning tree versions, spanning tree states, spanning tree guards, and some of the related features there. And then answer the question, why do some people say that we should just shut off spanning tree? We're going to pick up the conversation right where we left it off last week. Here we go. So, old school spanning tree, the original 802.1d. If you see 802.1d, that's what it's talking about. The original spanning tree was slow to converge. The timers took a while before everything settled down. And so not long after, we had a new version of spanning tree that was 802.1d, but faster. And I think with some other tweaks to it as well. That's 802.1w, called rapid spanning tree. So we got spanning tree, 802.1d, rapid spanning tree, 802.1w. The most key difference between the two is in the name rapid. It converges more quickly. The timers go more quickly. And now there's yet another one called multiple spanning tree. That's 802.1s, or originally it was 802.1s. The IEEE changed how they organized a lot of their standards. And for Ethernet, a lot of stuff got reorganized into 802.1q-2014. And 802.1s, multiple spanning tree, got pulled into that standard later on, 802.1q. So if you're reading about this, you might hear about 802.1s. Well, that's not the current one anymore. That's how it was originally published. It became 802.1, part of 802.1q-2014. Multiple spanning tree means you're literally running multiple instances of spanning tree on your switch, and you're mapping virtual LANs to the different instances. So a common use case for this would be, I want to, a common way you might see this implemented is even numbered VLANs are mapped to one of the multiple spanning trees, and you've got a second multiple spanning tree, and you map the odd numbered VLANs to that one. And the purpose of this, or a common from a network designer perspective, is with spanning tree, you end up with blocked links, right? And what traffic goes across the blocked links? Well, nothing. And so you're effectively wasting that link. What if I could have multiple instances of spanning tree on my network, where I make, for one instance, this is my root bridge, and for another instance, this other switch is my root bridge, and then I map different VLANs to each instance, and I can send effectively half my traffic across this one link, but in the other spanning tree instance, that link is a blocked link. Well, so now I get some amount of load balancing. I get to use some of that blocked traffic, some of those blocked links to actually carry some traffic. Yeah, that's kind of the idea there. Uh, so those are the standards: 802.1d, .1w, and .1s. But the one I see the most isn't actually a standard as such, but it's per VLAN. You'll see this as PVST, or if it's rapid spanning tree, rapid per VLAN spanning tree. That's like multiple, but every VLAN runs its own instance of spanning tree. So I just said many words. Have you? I don't know if when this was taught to you, if you remember any of this, or if you've seen like maybe any of your clients implement any flavors of this.
Um, no, I know about the original and rapid. Those two are pretty common. Um, multiple, I've never seen,
Yeah.
hadn't heard of before looking into the spanning tree stuff. And
Hmm.
then rapid per VLAN, I don't know if Juniper does this. I have no idea, but when I did research it, it was kind of a Cisco proprietary. That was where it originally came out. So haven't come across those two either. But again, I don't do much with spanning tree. So it
Yeah,
is
yeah.
possible that it exists somewhere in the networks that I look at, but
I don't know off
I
the top of
haven't
my head if
implemented them.
Juniper. I mean, if you're a network
Let's
vendor
see.
making a product, multiple VLAN 802.1s or
Mm,
later 802.1q 2014. That's like the quote unquote industry standard way to do it, but I didn't see it widely adopted out there. Haven't really seen much of it. It exists for sure. I've definitely worked with switches that run multi-spanning tree. If you're in a Cisco shop, as you noticed, per VLAN spanning tree, or more typically rapid per VLAN spanning tree, is really common, where every VLAN's got its own instance of spanning tree. And the way as a network designer you take advantage of this is kind of like I was trying to describe for multiple spanning tree. You end up using it as a load balancing mechanism.
mm.
Hey, somebody's going to get blocked in this spanning tree topology if I've got redundant links, but I hate wasting links. I don't want an Ethernet link to be sitting there idle. So some of the spanning trees, I'm going to set the root bridge to be one switch, and other of the spanning tree instances in these other VLANs, I'm going to set to have a different root bridge. And then the way it all converges, for some instances of spanning tree, that's a blocked link. For other instances of spanning tree, that's a forwarding link. And so you get some traffic across those links. Is typically the way that is implemented, or if you bother messing
Yeah.
with it at all. It all depends on your network layout. It all depends on how you've got things plugged in and what your constraints are, whether or not you do it that way. But that's a common way you might see it deployed.
Quick Google search, you can do per VLAN on Juniper stuff. I just have not come across it. So good to
Okay,
know.
there you go.
So
It,
also, I mean, things are called when they're not standard uh, protocols. They are called different things across all vendors. So I had to figure out what the acronym or whatever
it's
is used.
And that's called differentiation. We do the same thing, but we gave it a different name, so it's different. Yeah. The Can you think of the negatives of running a bunch of spanning tree instances on a switch, Holly, just from a practical standpoint?
Well, I mean, it's doing double the work. You now not only if something goes, you're not only converging one spanning tree instance, but now you have to work with multiple.
Yup. That's it. That's exactly the thing. And the more modern the switches, the less likely that is to be a problem, especially if there's not much churn in your network. Spanning tree doesn't have to do much if it's a stable topology. If links are always coming up and going down and switches are appearing and disappearing and so on, which might be more likely in maybe a large metro network or something, then spanning tree churn and the number of instances could be a thing, I guess. But for the average network, especially in like higher ed and enterprises where there's a lot of stability and not a lot of changes in churn, not really a problem. But that's exactly right. Now you're asking the switch to track not just one instance of spanning tree, but several, one per VLAN. And every time you add a new VLAN, you've just fired up a new instance of spanning tree. So that can be a thing. Okay, so another thing we want to talk through, spanning tree states, and this is going to inform some things about our edge ports. And I want to talk through spanning tree states before we talk then a little more about edge ports. Uh, Spanning tree ports go through and spanning tree bridges go through a bunch of different states as they figure out what the spanning tree is. They go through that convergence process. And they start out, because they don't know if there's a loop or not, they start out not sending traffic anywhere. Things are blocked. Everybody's in this blocked state. Like, I don't know. Maybe it's safe to send up, but we don't know until we listen to all the BPDUs and figure out who the root bridge is, and et cetera, et cetera. And so when switches first come up, they go through this process of, we're in a blocking state, and then we're going to transition to a listening state. I'm going to process BPDUs. I'm going to see if I'm going to listen long enough to know confidently who the root bridge is. And then once I think I know who the root bridge is, I'm going to go into a learning state. I'm going to listen for Ethernet frames of traffic that are being sent towards me and begin to populate my forwarding table and so on. And now it's like, okay, everything's stable. I haven't had any BPDUs tell me anything different than what I think I already know. So I think we're good here. I'm going to start forwarding. And then when we move to the forwarding state, everything's normal. So we go block. We're blocked, and then we're in our listening, and then learning, and then forwarding state. The other state that's kind of an oddball one that doesn't really have much to do with spanning tree is a spanning tree disabled state. And spanning tree doesn't put something into disabled state. You do, as the network engineer. Interface is in a shutdown state. I've disabled the port. And spanning tree looks at that and goes, oh, I see that you're a port, but you're disabled. So you don't matter to me. Go away. Kind of thing.
So when we thinking about all these states and spanning tree going through them, in my mind, if all the switches are in a blocking state and then come out of that blocking state all at the same time, then they kind of all in sync. So would they maybe pick a random timer, like I know some other protocols do, and say, okay, I'm going to stay blocking for X amount of time, and then I'm going to come out so that I'll listen, and maybe something else is a stage ahead of me and sending me BPDUs, or how does that work from a timing perspective?
It happens based on BPDU receipt and whether anything's different.
Mm-hmm.
Because BPDUs propagate from bridge to bridge. When initial BPDUs go out, no one knows who the root bridge is, including the root bridge. All they do is announce in their BPDUs what their priority is, and then they receive a BPDU. Oh, I just got a BPDU that's got a lower priority than me. That's my root bridge. And then that switch will share that information to its neighbors, and it's going to generate its own BPDU that's got the new root bridge information in it. So the transitioning happens once there's no new information being received via BPDUs, which could happen at different times by different switches because there's a propagation effect going on. BPDUs only travel one hop away, and then the switch that receives the BPDU generates a brand new BPDU with additional information, the new cost, and so on. And so the transition from into the next state is going to happen once BPDU information is stable. Nothing's changed. I haven't got a BPDU that's telling me about a new root bridge, or who I have just discovered. Oh, that BPDU's got new information in it, lower priority, et cetera. There's a new root bridge out there. Then we transition, and that could, because there's a scenario of everybody powering up at once, but then there's a scenario of just a new switch coming up on the wire. Which is a different animal. He's not going to be synced to everybody else necessarily. So does that help? You're nodding your head yes. Is that making sense?
Yeah.
Okay. So we got our blocking state. Then we transition to listening. We're waiting for new information on BPDUs. When everything seems stable, we're going to go to learning. And listen for frames that are being sent to me, and begin to populate my MAC forwarding tables, so I know, this MAC address lives off of this port. I'm going to therefore put that in my MAC address table. And now we move to our forwarding state. Normal operation. I'm receiving frames. I'm forwarding frames. I'm continuing to monitor BPDUs. In case I get a TCN, a topology change notification. We got to reconverge. We're going to change things again. And then the one oddball one of the disabled state. I know you, I see you, you report, you're seen, but you're shut down. The admin shut you down, and so you're a disabled port. So story time. I want to tell you a little story here of something when I was first getting my head around networks and networking. I was a consultant at the time, and I was sent to a site where the customer was complaining that when they would power on a PC, I think it was a Windows box of some sort, sometimes it wouldn't come up on the wire, and they couldn't figure out
Hmm.
why, what was going on. Long story short, the Windows machine was using DHCP, Dynamic Host Configuration Protocol, to get an IP address, and that process would fail. And then the Windows machine. This goes back a lot of years, but the machine would just sit there on the wire like I got nothing. I don't know. I asked for an address, no one gave me one. I'm sad. Nowadays that would not be a prolonged problem, but it was for this customer because of just how old Windows was. The system would just sit there. I think it gave itself the automatic a PIPA address, the 169.254 address, which wasn't useful on that particular
Yeah.
network. It needed to get a proper IP address. The issue was the switch port it was plugged into was not configured as an edge port. When you configure something as an edge port, it does not go through blocking, listening, learning, and then finally forwarding. It immediately transitions to forwarding as soon as it detects that there's something connected to it on the wire. It sees, oh, Ethernet's got something on the wire. Boom, whoop, up it comes. It comes up immediately. So in the case of this client problem that I'm remembering from 25 years ago, probably, it was not configured as an edge port. The PC would boot. The switch would say, oh, okay, new port. I need to go through blocking, listening, learning, forwarding on this port with all the timers associated with
Yeah.
it. Everything takes a little while. Everything takes a little while before it finally is comfortable and confident that it can forward safely. While the switch port was going through those states, the PC was trying to come up on the wire and was sending out a DHCP request. Hey, I need an IP address, sending that broadcast out. It would go to the switch, and what would happen to that DHCP request, Holly?
I mean, nothing. It's waiting for BPDUs. It's not getting anything
Exactly.
else.
It's so in it, right. It would get dropped because that switch port was not in a forwarding state. That's all going, that's happening on the switch. It's working through, it's listening, learning, forwarding, and the PC is connected to a port that it thinks is up. It's got signal as far as it knows. The network interface card thinks it's up. DHCP, please, someone help me. Would someone give me an IP address, please? And didn't get one.
Yeah.
Finally, the switch port would go into forwarding mode, but it was too late at that point. The
Yeah.
DHCP request process had failed. It got that a PIPA address. The solution then put the that edge port that the PC was plugged into, into edge port mode. Cisco would call it port fast mode. There is, if you're on Cisco Nexus, I think they actually call it edge port, and in Juniper land, I don't know what they call it. But the idea is, hey, this port is connected. It's at the edge. It's connected to a host. It's not connected to another switch. Transition to forwarding immediately as soon as you come up. And in which case, you no longer have the problem. And I had to do
Yeah.
some reading and figure this out. But I transitioned. I reconfigured that switch so that all the edge ports were configured as such. It was probably port fast. I don't remember. And boom, problem solved for the client. No worries. We're taking a break for a quick sponsor message from TrustGrid, a zero trust connectivity provider that gets you from anywhere and to anywhere. Let's dig into this. TrustGrid provides a network as a service for apps that need to securely access remote data. So maybe you're a SaaS provider that connects to a customer's network to interact with their database, or you provide a healthcare app that medical organizations need compliant access to. Or you're a fintech servicing banks and credit unions. You get the idea. Lots of encrypted, authenticated connections to lots of sites. That's the burden TrustGrid handles for you. You move the responsibility of deploying, maintaining, and supporting these networks to the TrustGrid team. And yeah, they know what they're doing. TrustGrid was built by network engineers so that you can retire the firewalls and routers you've deployed to remote customer sites. so that you never again have to get on the call with somebody to stand up an IPsec tunnel from your gear to theirs. If you're a networking or DevOps engineer, TrustGrid built this platform for you. TrustGrid is designed for applications running in AWS, Azure, Google Cloud, and private clouds. You can replace your enterprise VPN that connects cloud apps to on-prem data sources. TrustGrid tunnels are configured automatically, and that configuration is backed up automatically. TrustGrid nodes are patched programmatically. Plus, TrustGrid is keeping up with modern monitoring, supporting new standards like OpenTelemetry, as well as traditional SNMP v3 and flow records. Intrigued? Visit trustgrid.io/packetpushers to create up to 10 free network connections. That's trustgrid.io/packetpushers and try out the free tier. And now, back to today's episode. What is the risk of transitioning directly to forwarding, Holly?
Well, if you have a device that gets plugged in and it's not a host or something else, you now possibly, let's say, for some reason, someone connects a switch in there, you're immediately creating loops without it checking anything else. It's not going to converge. You've got problems.
You definitely could be creating loops. You maybe
Yeah.
you are, maybe you're not. But what you're doing as a network engineer is you're saying this is an edge port. The only thing I'm plugging in here is a host, and you're telling the switch basically, trust me, you're never going to have another switch sending you BPDUs from there where you have to worry about spanning tree topology in
Hmm.
this layer 2 domain. That's basically what you're saying. You're saying, trust me. Only in every network I've worked on, someone will bring in a little Linksys box from home because, I mean, this is kind of an old school thing, but people would bring in like their little Linksys router from home, could have had a built-in wireless access point, and they wanted to do wireless with their laptop and wander around the office because maybe we weren't offering wireless in that office or something. Well, that little Linksys box was a switch. And so they'd plug that into their host, and all of a sudden we've got this potential for a loop to be created. I've also been in scenarios where someone will bring like a little 8-port switch into a conference room because they want to plug in, everybody wanted to plug something into that 8-port switch. And they'll get the wiring wrong. There'll be 2 ports in the conference room that go back to some closet switch. They got the little 8-port switch on the middle of the conference room table, and they'll somehow or another, because cables are messy and they're hard, plug both ports in the wall into that 8-port switch, and they just created a loop. That's a
Yeah.
thing now. To prevent that from becoming a problem, if you've got edge ports configured with port fast or edge port or whatever the command might be on the particular network device you're working on, there are some different guards that are in place. BPDU guard is one of them. So on a port fast or an edge configured port, if you've got BPDU guard configured, and if a BPDU is received, then the switch goes, oh, somebody did something bad. Boom, I'm going to shut that port down. So that's a protection you have so that if someone configures a loop, as soon as that BPDU is detected, the switch goes, the switch port, not the switch, but the switch port that detected the BPDU showing up unexpectedly on an edge port gets shut down. So that's a if you do,
Yeah.
so therefore, if you configure port fast, you should be configuring BPDU guard as part of that as well. As a network engineer, that's like a good design practice.
What happens after? So BPD guard brings that port down.
Yep.
How does it? Do you have to manually bring that port back up, or when you plug in something that's correct, will it say, "Okay, we good, we can bring it back up"? I guess the
The
port's
answer
disabled,
is it is
so
possible that it might bring itself back up depending on the switch and what its capabilities are. But in my experience, you always, as the network administrator, have to turn that port
yeah,
back up. You have to take it out of the error disabled state. And by going through either a shut, no shut cycle, something like that, where you manually disable it and re-enable it to start that over again. But I'm just speculating here that depending, it could be a timer-based thing. Like, hey, if it's clean and there's no BPDUs that have been seen on the port after X amount of time, then it's okay to re-enable it. That's possible. I just can't think of an example of where I've run into that personally. So, and there's
Mm.
a lot of network operating systems out there. I don't know. Mostly it's a manual thing, and someone's going to be like, conference room switch ports don't work anymore. Then you go and look and like, okay, who plugged in the switch? Come on, dude, confess. No, so there's another related guard here. That was BPDU guard. There's also BPDU filter, which behaves differently. If someone plugs in a switch and sends a BPDU, just drop the BPDU. Don't disable the port, but drop the BPDU. Uh, I can see that if you know, like, okay, in this a conference room, we actually need that 8-port switch in there, and it's going to be okay. I trust them not to create a loop. It's going to be okay. I want to filter the BPDU rather than have the BPDU guard disable the port.
Mm.
But I've never run BPDU filter myself. I just never been entirely comfortable with that. But I can see certain very specific controlled scenarios where maybe that works. But for me personally, nah. I'm gonna stick with BPDU guard myself. But that's the difference between guard and filter. Guard, shut the port if you see a BPDU come in on that edge port. Filter, just drop the BPDU. Don't, because we don't want to like cause a topology change notification to get sent. There's not going to be a loop. We're going to be okay. Don't tell spanning tree that there's another switch hanging off there. We don't want it to know. That doesn't work for me. But anyway, so far so good.
Yeah.
Okay. One more guard I'll mention is this podcast going on a long time, Holly. I'm sorry, listener. Maybe this should have been 3 parts. But one more guard I'll mention is root guard. And it's kind of like the purpose of BPDU guard. The idea is to make sure no one else shows up in your spanning tree domain. No one else, no other bridge shows up in your spanning
Mm.
tree domain claiming to be root. So if someone plugs a switch in that's got a lower bridge priority, let's say, than your root bridge, and you know this is the guy, this is the root bridge, no one else should do that, you can enable root guard, and you would put that on a designated port. And then if a superior BPDU comes in, hey, I'm the one that should be root. I got the lower priority. Look at me and make me root. Instead of going, oh yeah, okay, let's have a convergence event. We got a new root bridge, everybody. No, I don't want that. Instead, if you got root guard configured on your designated port, you're going to disable that port, and it'll show up as root inconsistent and root inconsistent. Someone else just showed up on the wire who thinks they should be root, and no, because you as the designer are trying to
Yeah.
enforce a very specific topology. Is where you'd use root guard. Good?
Yeah.
Okay.
Makes sense. I mean, why would you've set your network up in a very specific way. These are all methods to protect it from going off the rails. So,
Which, to me, you want to set this up in a very specific way. That is, most networks I've walked into, very often I've had like the firefighter outfit on, and they parachute me in to fix a bunch of problems. Spanning tree will be left to defaults, where it's all willy-nilly and everybody's got the same root bridge priority. A root bridge is elected somehow, with tiebreakers and so on. And it's not an intentionally designed spanning tree. So if, as a network engineer, you purposely design the spanning tree so you know who your root bridges are and you know which ports you've blocked and why, and you've purposely put a redundant link in because reasons of the way the building is laid out or where your cable runs are, or you've got reasons why you've done that, you want to protect that. So your edge ports are going to have BPDU guard and your designated ports are going to run root guard. And then if someone does something unexpected, someone's in the lab and they're configuring a new switch and they plug it into the prod network accidentally, not thinking about it, like, oh crap, you're protected from that. Your production environment, it remains stable. Going back to our talk about convergence, when spanning tree convergence happens, there's a hiccup in the network, right? There's a disturbance in the force. You don't want that to happen during the middle of the day. That's a bad thing.
Yeah.
So with spanning tree, these guards can help prevent that kind of thing from happen. Oh boy, there's so much more to talk about, Holly. So, but let me pause here and see, as we've talked through all this over these last couple of episodes, what questions have come up, or comments or thoughts that you have?
So far, so good. I mean, I think there's still a couple questions that are lingering from the original question, like why does everybody tell you to turn it off? Up until this point, it's like, well, this sounds great. Every switch knows their role. We have no redundant links. We prevent loops. All is good in the world. But that is definitely the question lingering over my
Okay.
head, and the manner in which things come up. Lots of post post questions after everything's running and doing well. So,
So why do some people, many people even, say you should shut off spanning tree? Or why do people think that spanning tree causes loops? I've heard that one too, a
yes, I've heard that
variation. Yeah,
too.
yeah. Um, Spanning tree doesn't cause loops. We've talked about how it works and what it does. It does the opposite of that. Some people say shut it off because of the change thing. I plug in a new switch, which causes a topology change notification, which causes the hiccup in the wire, and everybody freaks out. And that's it, honestly. If you have, you can get away without spanning tree if you know exactly where you've plugged everything in and there's no loops. The problem comes in when you accidentally create a loop, which is stupidly easy to do,
Yeah.
unfortunately. Like there are certain hosts that, if they, depending on how their networking has been configured, like a Linux box, it's possible to turn that device that has two network interfaces, each of which are plugged into a switch, uh, into a device that creates a loop because it's got two NICs, and there can be bridging that happens inside of that host. That's not common, but that's certainly possible. That is a thing that can happen, and I've seen it happen. There are scenarios where you are configuring an ether channel, a port channel, and you plug things in wrong. You had configured the switch. These are my ports that are going to be a member of the port channel. And then you plugged in one of your cables to the wrong port, not one of the ones you configured, and you just created a loop. That can happen. The conference room scenario, that's happened to me multiple times, where
Yeah.
be- you trace out all the wires because somehow there's this rat's nest of wires between what's under the conference table, what's on top of the conference table, what's going to the wall, power cables, and all the rest. And people who aren't network engineers don't know what they're looking at. They're just plugging stuff in, trying to make something work. They'll create a loop that way. But in theory, if you had perfect control of your network, do you need spanning tree to prevent the loops? No, you need you as the human to plug everything in correctly and prevent the loops, and you'll be fine as long as you haven't created a physical loop by plugging in cables wrong.
Hmm.
You're good. Everything's good. So you can get away without that, and then you never have a convergence event because you're not kicking BPDUs around and causing switches to react. And topology change. We gotta pause for a minute and rethink about things. Um, because people don't understand the spanning tree and what it does when there is a broadcast storm that happens, they can say, "Oh, that's a spanning tree loop," or "That's a." It's it's just a misunderstanding of how it works and what it's meant to do. Another challenge here that I think I mentioned in the last episode: what happens if there is a broadcast storm, but spanning tree is relying on BPDUs to know what the
Mm.
topology of the network is, but because we're in the middle of the storm, BPDUs are being lost because the network is so noisy? Then spanning tree can't function
Yeah.
because it's not getting the messages it needs to run the algorithm and know how to converge correctly. That's a scenario that could happen. Um, I've seen it happen that BPDU guard was configured on an edge port. Someone plugged a switch in. BPDU card didn't catch it. It didn't disable the port quickly enough, and a loop was formed. I have seen that
Mm.
happen. Now that I would blame more on like network operating system kind of thing. Like, you
Yeah.
should have caught the BPDU, but somehow in your control plane, you guys missed it. But that's a thing that I've seen happen. So do you want to shut off spanning tree? I mean, there are network topologies where I don't see the benefit of spanning tree, and those are layer 3 networks. That's part of what you work with like EVPN VXLAN, where everything's got whatever the underlay is, and it's got BGP and so on. Everything's routed. There is no big layer 2 domain anywhere because everything's been converted to layer 3. What is the advantage of running spanning tree in that environment? Making a lot of assumptions, probably none. As you say in the cookbook to build BGP EVPN in your world at Juniper, I believe you told me there's no spanning tree discussion, right?
As far as I'm aware, no.
Yeah.
So, I
Yeah.
mean, why would you need it? I guess
And that's from my
there's
brain. It's like,
just
why
yeah,
would you need it? Um, and honestly, with layer 3 networks, that is part of the evolution of networking. Layer 2 networks with spanning tree are wasteful in that you end up with a blocked link. And I was talking about per VLAN spanning tree and
yeah,
multi spanning tree as a way to kind of work around that blocked link scenario where you can have the blocked links carry traffic for some VLANs, but not other VLANs. So you're not wasting that link entirely. Now we're at a point where if you've got a 100 gig link, 200, 400, 800 gig link, those cost money. You don't want to have it sitting there idle as a just in case I have a redundant link. So we use layer 3 networks to overcome that. We use port channels to overcome that, various ECMP equal cost
hmm
multipath to overcome that. Because if you just use spanning tree by default as it was originally conceived, what are we talking, 45 years ago now, something like that? Where the networking was a very different discipline and the concerns were very different. It's a different, it's different times, different times. I look at spanning tree as you've still got layer 2 networks of size and a lot of networks, and you use it by actively, thoughtfully configuring it to help you to save your network in case a loop
yeah,
accidentally shows up. Um, but it's not you want to eliminate those blocked links as much as possible. I've never built a network where I intentionally configured a loop. I mean, almost without exception. I've never built a network where I intentionally configured a layer 2 loop link, a redundant link, as a just in case. All my
yeah.
redundancy was in the form of port channels or some kind of equal cost multipath. So I never had idle links. I mean, almost never. It depends on which network we're talking about and what the situation was. But there's always exceptions. There's always exceptions. But um, yeah, modern networks now. I mean, there's another thing we haven't talked about at all here in this discussion about spanning tree, which is there are two other layer 2 technologies that were meant to be the successors for spanning tree. Those are Trill and SPB, shortest path bridging, which is
Mm.
layer 2 that functions more like routing as opposed to spanning tree with this figure out the path back to root bridge and block the other link. They're layer 2 as opposed to layer 3, so they're dealing with frames, but they look more like it functions more like a router would function as far as how they do their forwarding decisions. But they became flavor of the day. They were hot in the mid 2010s, I would say.
Mm.
You saw a lot of Trill and shortest path bridging related products, many of which are still in production in different parts of the world. As I understand, there's some service providers that are doing some big shortest path bridging networks because there's use cases for that technology, and they are really the successors to spanning tree. But not a lot of enterprises really deployed that. If you were in the Cisco world, there was a product called Fabric Path that is Trill under the hood, as I recall. I don't know that Cisco pushes that too much. I mean, Juniper had some flavors of this, as I recall. I don't remember. I mean, you guys went big into
Would
the
have been
virtual
before
chassis
me. Yeah.
space. Virtual chassis were because of when we talked about those in an earlier episode, they kind of make a bunch of disparate switches act like one big switch.
Yep.
Kind of solves the same problem, but in a very different way. There's a lot of this technology that we see in the networking space is because spanning tree kind of sucks in a lot of ways. But don't just shut it off unless you understand exactly what you're doing and why would be, my advice.
Which maybe to the people who really aggressively hate it, maybe it comes back to a bit of a user error problem where you have something that's set up, and if you aren't 100% intentional with everything you're doing, there will be problems. And spanning tree, as it's meant to do, is going to take time, and things are going to take time to fix what you've done. So
Yep.
maybe it's not really the protocol, but maybe it's the user that's the problem with
Yeah.
spanning tree.
Very often that's the case, and that's the harsh reality of it. Is very often it's us, it's those of us doing the configuration that get it wrong, and we blame the thing we don't understand because we don't understand it, rather than going, ah,
Yeah.
crap, I got to learn this, and really
Hmm.
get control of it. Sorry, listener. I know Spanish is a big topic, though. Hopefully, you guys listening got something out of this. If you've got questions about it, uh, do let us know. You can hit packetpushers.net/follow up. And Holly and I are going to chat with you again next week. We got more jargon, concepts, big ideas from the world of packets coming at you. And again, if you hit that packetpushers.net/follow up, it doesn't have to be just about this episode. Like if you've got like, would you guys talk about something, whatever the thing is you want us to talk about, we'll dig in, do some homework, and figure it out for you, and share it as best we can. If you'd like to connect with Holly or I directly, you can do so via LinkedIn or the Packet Pushers Community Slack group. Again, I'm Ethan Banks. Holly is Holly Metlitsky. You can find us pretty easily on those places. And the community Slack group is available to you for free at packetpushers.net/community. We got lots of channels in there to talk about anything you want to talk about. There's a labbing channel. There's a campus networking channel. There's a routing channel. There's a channel just for the N is for Networking podcast that Holly and I keep track of, and so on. Lots of other resources for you at packetpushers.net, and they're all free. You don't have to log in. They're just there. There's a dozen podcasts that you can subscribe to that, like cybersecurity, go to the Packet Protector podcast. You really into wireless? We got a show called Heavy Wireless, etc. We got weekly newsletters. We got a YouTube channel, lots of stuff. Again, it's all for free. And please share N is for Networking with your colleagues. Holly and I would really appreciate that. And just remember that networking isn't hard. Other people figured it out, so you can too.